All right. In what three forms can you write a rational number? So this is lesson 1, unit 6, the final lesson, the final unit of the 7th grade school year. So I know you're sad. Okay. But you know what? You guys will have your notebooks with you to look at anytime you miss this class. For those of you that cherish the notes that you took in class, and you'll have that memento to take with you. Gloria Bell in the back, she doesn't want to be reminded of the pain of not being in math. So she said that she's going to throw away her notebook. It's okay. It's okay. Gloria Bell, it's good that you're talking this out. It's good. That's good. Good. I feel like we're healing. Already. So, vocabulary review. In what 3 forms can you write a rational number? Can somebody give me one form? And then I'd like to hear 3 from 3 different people. Olamide, give me one form.
I use the variable numbers x and y to represent a number. Well, that makes no sense.
You're overthinking it. There's 3. What are the name of the 3?
No, because to make the place of a number, I use x and y as letters.
Timothy. A fraction, yes. That is one form. Who's got the next form? Gloria Bell?
Is it a percent?
Yes, a percent. Miles, he wants to
Just decimal.
cherish this answer that he gives. Decimal. Decimal, very good. Okay. Hey, and remember, you can always click on the YouTube channel if you ever want to hear a video this summer. Number 2, who can tell me numbers 2? Number 2, Carter, what's the answer to number 2?
So for the decimal, we got 62 hundredths.
Okay, how did you come up with the decimal? Tell me your strategy, because I feel like there's an easy way to go about this, and then there's a longer method. What was your method?
I divided the numerator into
So you did long division.
Yeah.
Okay, and so if you did long division, that is correct. It is, what'd you say?
6200.
Okay. Who had a shorter method? Christian.
So I know that half of 100 is 50. So I did find half of.
So, very good. So if you take this and come up with the equivalent fraction, you know that 50 times 2 gives you 100, and so 31 times 2 gives you 6200, right? And remember, when you have a fraction where the denominator is 100, that's literally what percent translates into. 62% per 100. Okay? So either method, one method was a little faster than the other, but the go-to to write any fraction as a decimal is to divide it out, long division. Okay? Who has number 3? Who can tell me what number 3 is? As either give me one or the other. Ola.
Can I say both?
Give me one.
Okay. 9500s.
9500s. How did you do that?
20 divided by 19.
Oh, so you actually did long division. Okay. And what did you get when you what did you find?
9500s.
You got 9500ths. Okay. Who had another method that might have been a little bit faster? Gloria Bell.
So I knew that 20 times 5 equals 100. So I just multiplied 19 by 5 and it got me 95.
Nice. So you saw that I can rewrite this fraction as an equivalent fraction with the denominator of 100, and you recognize that a factor of 5 takes you from 20 to 100. So 19 times 5, you got 95 in the numerator, and we know that 95 hundredths literally translates into 95 percent. Good. Number 4. Who's got number 4? By the way, if you're sad about not having math and you send me a webmail over summer, I'm on vacation. I will not respond to any of it. If you ask me for a math problem, I'm going to say too bad. Out of math problems on vacation. Who's got this one? Who's got this one? Somebody. Oh, you already spoke. Somebody. Joseph, what do you got? Oh, you're doing number 5? Oh, we can do number 5. We'll backtrack to number 4. Go ahead. So you rewrote this as an equivalent fraction with a denominator of 100. Very good. And so what's the numerator going to be? 110. Okay. And so what's the percent going to be? Can somebody help him out? Because I think once he sees the answer, he's going to be like, oh, really? Rudy? Oh, you got for the decimal when you divide it out? Okay. 1 whole and 1/10, right? No, that's correct. But I'm looking for the percent. What is this written as a percent? Who's got this? Timothy? 110%. Okay, number 4. Who's got number 4? Olamide, what'd you get?
Okay, I got 27.5.
27.5? Did you guys get that?
Yeah.
If I recall correctly, I believe that's it. But let's go ahead, because this is the only one that the numerator, the denominator is not a factor of 100. Or did you have another way around it?
Another way.
Okay, what'd you do? I'm just curious.
So first, what I did was I backtracked it, so I divided 40 divided by 2, and then I
Okay.
divided,
So you saw that 40 goes into 100 twice and a little bit more than that, right?
So I
That's
divided
good.
40 by 2, and I got 20, then I got 11 by 2, and I got 5.5.
So the factor that takes you from 40 to 100, 2 gets you to 80. What takes me to 100?
25, 20.
2.5, right?
Yeah. I also was 6 point. Okay, so 2.5 and then 2 point. No, I said 5.5. Sorry, I meant 5.5.
No, that's okay. I know what you meant.
11 divided by 11 divided by 2 is 5.5.
Okay, so then you took 11 twice, and then you...
Divided by 5, and I got 27.5.
Oh, okay. Okay, so I liked how you used some mental math, but the result's the same.
Yeah.
If I took 11 and I multiply by 2.5, well, 10 times 2.5 is what? 25, right? And 0.1 times 2.5, you're just moving your decimal how many places? So 25 plus, what's 1 times 2.5?
2.5.
Right? So isn't 10 times, because hold on, watch this. And this is some distributive property that we did in the past, right? So 2.5 times 10, isn't 10 plus 1, 11, right? So we can say 2.5 times 10 is 25. We get that, right? Okay, and 2.5 times 1 is 2.5. And so if I take 2.5 plus 25, what's that going to be?
27.5.
Okay. Okay, and what does that simplify to? 27.5%. Okay, or you could have done the long division, right?
Wait. Look at my notes.
What would the decimal be? Come on, if we go from a percent to a decimal, remember which way we're moving our decimal point? Away from the percent sign, right? So what would this be as a decimal? Olamide, I think you said it earlier, but Timothy, what is it?
2 and 75.
Nope. Fatima?
It would be 275,000.
tens, hundreds, thousands. Very good. So 0 to 75. Nice. Okay, that's it. I know some of you guys need to dust off the cobwebs up here. We covered this in the fall, but now that you've seen it, we're good. We saw it a couple times throughout the school year. We didn't do it long division. We just did another mental math using Okay, so here I'm going to go and read this. What you'll learn: to find the probability and the complement of an event. Okay? Outcome, event, theoretical probability, complement. Why learn this? An outcome is the result of an action. For example, getting tails is a possible outcome of flipping a coin. Okay? An event is a collection of possible outcomes. If all outcomes are equally likely, you can use a formula to find the theoretical probability. Okay, so let's think about this problem. Here's the key concept: theoretical probability. Okay, so think about P as the probability, and in the parentheses is whatever the event is. If we said the probability of tails, they would write it this way: P, tails, and they're talking about what's the probability of flipping tails on a coin? 1 out of 2, right? Because the number of favorable outcomes would be what? How many tails are there on a coin? 1. And then the total number of possible outcomes, how many?
2.
Right, there are 2 because you have a heads and tails, right? So my top number would be 1 because there's only 1 tail on a coin. My bottom number would be 2 because there's 2 different possibilities. There's the tails and then the heads. Got it? Okay. So the probability of flipping a coin and having it land tails up is what percent? What percent goes with a half? 50%. 50-50 that I'll flip tails. Okay? Now, you can express probability as a fraction, a decimal, or percent. So that's kind of what the warm-up was about. Okay? But you see that using this formula, it's about the fraction. Okay? Number of favorable outcomes over total number of possible outcomes. All right, so let's take a look at this. You select a letter at random from the letters shown. So you guys ever play Scrabble?
Yes.
So say we took, these are all of the letters. There's 5 of them. You flip them over, you mix them up. You select a letter at random from the letters shown. Find the probability of selecting a vowel. Express the probability as a fraction, a decimal, and a percent. So I need you guys to think about the key concept quickly to yourself. Write it out. Quietly. Shh. You guys are trying to play Scrabble. We're trying to figure out the probability. Focus. Focus. You guys are like cats with the laser beam. Shh. Focus. Are you going to give me an answer? You're not going to ask me a question that's unrelated? You sure? Okay, Christian.
So, in the letters we have 5 different letters. And
Okay.
of the 5 different letters, 2 of them are vowels.
So, what number goes on the numerator? What number goes on the denominator?
The number that would go on the numerator is 2
Why'd you say 2?
because there are 2 vowels.
Very good. So we have 2 vowels. I'll circle those.
The number that would go on the bottom is 5 because we have 5 total numbers.
5. Good. So we have 1, 2, 3, 4, and 5. Okay, very good. Okay, so really quickly, this is the probability of what? What would we call this event? Vowel. You can put in here vowel. Okay. The probability of picking a vowel is 2/5. Okay. And then, can you give me another way to write that?
So we would have a decimal, and the decimal would be 40 hundredths.
40 hundredths. Is there a better way we could say that?
4
I heard it. Thank you. 4/10. And then how would I write that as a decimal? Who can what would that be as a decimal? 40%. Okay, any questions about this? All right. Okay, we good? All right, same problem, but guess what? We want to know the probability of selecting a consonant. So we already figured out the probability of picking a vowel. Now we got to figure out the probability of selecting a consonant. When you're done, put your pencils down so I can have somebody discuss the answer with the class. Alexandria, explain to us your answer. Fatima, stop creeping her out. So look, do you see the example that Christian just did? The probability of selecting a vowel. Okay. Here's the key concept above. Take a look. So the probability of the event is equal to the fraction where the numerator is how many favorable outcomes they are. In this case, what are my favorable outcomes? What do we want to happen? What do we want to happen? We want to pick what? Right. So how many of those favorable outcomes are there? There's 3. And the fifths come from all the possible outcomes. So correct. Okay. So 3/5 is the fraction. What's my decimal and my percent? And what's the actual name of that number, 0.6? 6/10. And then can you tell me that as a percent now? 60%. Very good. Okay. Any questions? Are we good? Okay, next problem. Okay, now, in that last problem, were you more likely to pick a vowel or were you more likely to pick a consonant? Okay, and if you think back, what was the percentage probability we would pick a vowel? 40. What was the percentage probability we'd pick a consonant? Now, you said it was more likely or more probable to pick a consonant, right? Now, if you have all of your favorable outcomes and you figure out the probability of each and you add them together, you should get 100%. What's 40 and 60%? 100%. Does that make sense? So I just want to go back to this. The number equivalent, the decimal equivalent to 100% is what? 1.0 or just 1. Okay, so take a look at this number line, and do you see if it's no probability, it's 0%. Got it? So impossible. And then as you approach 1 or 100%, 100% means it's definitely going to happen. Got it? Okay. So all probabilities range from 0 to 1. The probability of rolling a 7 on a number cube, a dice, they call it a number cube dice. Is there a 7 on a dice? No. So is it possible to roll a 7? No, that favorable outcome is a 0. It doesn't exist. 0 doesn't even exist on a dice, so you still. Anyway, so that is an impossible event. The probability of rolling a positive integer less than 7 is right, because it isn't 1, 2, 3, 4, 5, 6. Aren't all those numbers less than 7? And so the favorable outcomes are how many? 6. Out of how many possible outcomes? 6. So 6 divided by 6 is? Right. That's 100%. So you guys see, like, certain event, impossible event. You guys understand the difference? Okay. The complement of an event is the collection of outcomes not contained in the event. So let's talk about what that is. The sum of probabilities of an event and its complement is 1. So if we talk about the event, so the example we used earlier, that's why I was trying to talk about that a moment earlier about the vowels and picking a consonant or a vowel. That's to illustrate this point right here. So Christian's example, the probability of a vowel we saw was what? The vowel plus the probability. And another, instead of saying, what's the opposite of, instead of saying consonant, we're going to say not a vowel. Okay? And we saw that that was, what was the probability of picking a vowel? 40%. It was 40%, right? Plus the probability of picking not a vowel, which is a consonant, was 60%. And we saw that that equals 100% or 1, and that's just to illustrate the complement. Okay? So the complement of picking a vowel is not picking a vowel. Do you guys understand? Okay. All right, moving along. All right. Finding probabilities from 0 to 1. Close. The picture shows jeans in Juanita's closet. She selects a pair of jeans with her eyes shut. That means she's going to pick it at random. Find the probability that she picks a dark color. Right now, I need you guys to, just like Park, I couldn't explain things to you. Right now, you're trying to figure it out on your own. We'll talk about it in a moment. Put your hand down. I want everybody to try. Yeah, once you come up with an answer. Okay, who can share with the class their answer? Miles, I haven't heard from you today. Go ahead.
5.
Wait, hold on. Remember, probability is a fraction. So come up with the fraction.
5 is.
5/8. How did you come up with 5/8?
I counted the darks and then no, I counted all of them together. Then I counted the darks.
Nice. So all of them together were how many?
8.
8. 1, 2, 3, 4, 5, 6, 7, 8. And hold on a second. I need you guys to know the vocabulary. So what do we call 8? The number 8 represents what?
Denominator.
Oren, can you help out? Nope. On the right track. Let's backtrack. Take a look right here in the notes. Total number of possible outcomes. So you were correct outcome, but we needed to kind of explain that a little bit more. I need you to stop and pay attention. So the total number of possible outcomes in this case was 8. There are 8 different pants that she could select, right, at random. Okay, the numerator, the favorable outcome is what?
5.
5. And so 5 represents, what was the favorable outcome? picking what?
8.
What was the favorable outcome?
The dark colors.
The dark colors. And we have 1, 2, 3, 4, 5. 5 dark colors. Actually, I put that in. Okay. And so the probability picking dark colors. Pants. Okay. Now, that's one way to represent probability. The other ways, I'm not going to spend too much more time. Okay. And then if I needed to write this as a percent, what's this as a percent? And remember, if I'm making a percent, I'm going to move toward 2 places toward where the percent sign is going to be. So it would be 62 and 0.5%. So that's some review for us. Now, what's the probability she's going to pick a red pair of pants?
0.
Right, because she has no red pair of pants. So in that case, probability is 0, 0%. Now, what's the probability of her picking not a dark color? Timothy. I don't know what's going on. I need you to get it together. Go ahead, Timothy. 3/8. How'd you come up with 3/8?
Because there are 5 color pants and so
Right. 1, 2, 3. We see she only has 3 out of how many total possibilities? Was 8. So 3/8. So here's our solution here. Now, I wanted to illustrate something, the complement. So if we know what it is that's the favorable event, picking a dark color, picking a light color would be not a dark color. Do you guys see that? So if there's either lights or darks, you could have calculated it another way. 1 minus 5/8, 3/8. So I just wanted to show you the 2 ways, and I want to relate what we covered earlier with complement. Okay, do you guys understand? Any questions? Yes?
I did not know that blue counted as a dark color. Yeah. That's why they invented light blue. But that's why they invented a dark
Well,
blue.
I hear what you're saying. Shh, shh,
That was
shh.
dark blue.
I hear what you're saying. You have blue jeans that could be really light colored blue jeans, or
Then that would be light blue.
right? But I will say from the picture in the book, they were considering these blue jeans as dark colors. And if you've ever washed a new pair of jeans, you know you don't want to wash your brand new dark colored blue jeans with light colors,
Yeah.
right? Because the colors will, the dye will bleed off into your other colors, other non-dark clothes. Okay, so there's a reason why you wash and separate the laundry the way you do. All right, here we go. You roll a number cube. The book calls it a number cube. It's just a dice. You roll a number cube once. Find the probability that you're going to roll a multiple of 3. A lot of you, I can tell you have ideas about this. I want you guys to put it on paper and see if we're right. We'll discuss it once everybody's tried on their own. Shh, quietly to yourself. Please stop throwing paper. Pick that up all around the desk. Who haven't I heard from? Tayana, can you help me out? What's the numerator of my fraction going to be?
6. I mean, no, not the numerator. The numerator is going to be 3.
So there are 3 multiples of 3 on a dice?
Wait, no.
How many multiples of 3 are there on a dice? So let's count by threes.
Oh. 6.
So how many? Count by threes.
Oh wait, no, 2.
2, very good. So the favorable outcomes, there's going to be the number 3 and the number 6. Those are multiples of 3, right? Now, how many possible, what are the total possible outcomes? There's 6 of them, right? 1, 2, 3, 4, 5, 6. Okay, so here it is. I need you to move over here.
Me?
Yes. And I need all that paper to go in the trash. And if I see another paper thrown, I'll see you at the end of this. I'll see you at lunch today. So we're taking the focus off what's important, and we're putting it on this nonsense right now, and I don't appreciate it. Glorabelle, can you... Now, listen, I had to simplify this to a third. We already know how to write a third. That's one of the fractions that we learned about, the repeating decimal. That's one that you should kind of memorize, okay? 2/3 is another one, 0.66666, and so on. So now, how about this one, the next one, the probability of not a multiple of 2. Window seat. Go ahead, work this one out. Up one. That one right there. Lorbo, what do you think it is? 3 out of 6. What numbers would I need to roll? What would the numbers be that are multiples, that are not multiples of 2? 1, 3, and 5. Very good. So that means you have 3 favorable outcomes. And then out of what are my total possible outcomes? 6 again, doesn't change. Okay. All right, and here, this is an easy one. The probability of rolling a 9. Is there a 9 on a dice? 0.
One of those wizard dice, yes.
They said a 6-sided one. Okay, a cube. They said a number cube. Okay, we're not talking about like the Dungeons and Dragons special game dice or anything like that. Okay, we're almost done. Define event without using the word outcome. Who can do that? Uche, I haven't heard from you today. Go ahead. Okay, I think I like your creativity. Amani.
An outcome is a result of an action.
Okay, so you read the definition, but now answer the question. The question says, hey, define event without using outcome. So take that and reword it without outcome in the definition. Rudy, can you help him out?
It's the thing you're trying to find the probability of.
Okay, Christian, how about you?
An event is a collection of possible results.
I like that. I like that. The result. Okay, an action.
See, that's light blue.
Yeah, that's light blue. Okay, find the probability. Find probability of A equals, write expression for probability. Okay, so they want to know the complement. So they're giving you the probability of an event. In this case, it's just a generic event, A. What's the probability of the complement of that event? Remember what we talked about earlier? We had the 2 examples, and the probability of an event and its complement, what's the sum going to be? 1. So tell me what the probability is. What's the expression for the probability of not A, the complement of A? Carter? 2/3. Do you guys agree? 2/3? Yes. And here's the expression. I'm solving the equation. So probability A plus probability of the complement or probability of not A equals 1. So we know probability A is 1/3. We don't know what this is. You were able to solve it mentally, okay? Sometimes it might not be that easy. Okay, so set it up. Two events, A and its complement, the sum of them equal 1. Solve for it, and then Carter's absolutely correct. It ends up being 2/3. All right. Next example. And then I believe we are done. All right, so you select a marble from those shown. Match each event with this probability. What is the probability of selecting a red marble? Which one of these does it go with? Raise your hand, please don't call out. Joseph, what's the probability of selecting red? Which one of these would I match it to? 2/7, very good. There's 2 red, and there's 7 total marbles. What's the probability of picking yellow? Glorabel? 0, and there's no yellow. So there is no probability. What's the probability of picking blue? Oren? 5 blue out of 7 total possible outcomes. And then the probability of picking red or blue. What would it be before it was simplified to 1? 7/7, which would simplify to 1.